These are the 5.2 notes for Algebra 2. We're going to talk about our basic exponent rules. These are things you probably learned back in Algebra 1, but we're going to refresh. So you have three basic rules for exponents. The first one is if you are multiplying an x times an x, and this works for any variables. When this happens, you are going to add the exponents together, resulting in x to the 8th. For rule number 2, when you are dividing, we are going to subtract the exponents. Another way I like to say this is, where are there more exponents? And I'll kind of explain that as we go through this lesson. This is going to help me with some negatives. For right now, this one, 5 minus 3, would just give me 2. If you thought about the where are there more, I would say where are there more exponents at the top or the bottom? So 5 compared to 3, there are more at the top. 5. How many more? 2. So you would have x squared at the top. Rule number 3 is when you raise a power to a power or an exponent to another exponent. And for this one, you're going to multiply the exponents. So you would do 3 times 5 to make 15. All right, so we're going to take those three basic rules and just expand on them, do some more complicated problems. Now, the numbers on each of these are going to work the same way as they always do. So anytime you're multiplying numbers, you just multiply them. Dividing, you just divide or reduce. All right, so example A, you're going to multiply 7 times 2 to make 14. Then you're going to add 5 plus 10 to make 15. And add 2 plus 5 on the b's to make 7. So again, that was 7 times 2, but then 5 plus 10. And 2 plus 5. Okay? So notice the difference there. I didn't add those numbers, I multiplied them. All right, let's look at the next one. This next one looks like it's raising a power to a power. So this one's going to be when I multiply. So I'm going to do 3 times 2 to make 6, x to the 6th, and 6 times 2 to make 12, y to the 12th. That would be a rule of multiplying. On the next one, part C, 15 over 10. This is one I'm going to have to reduce the fraction, because it doesn't divide out into a whole number. So I have to think of a number that goes into both of those. 15 and 10 can both be divided by 5. So I'll do that to the top and the bottom. 15 divided by 5 is 3. 10 divided by 5 is 2. So I get a reduced fraction of 3 over 2. 3 will go in my numerator, 2 will be in my denominator. Now, the next part here is going to be when we subtract or ask ourselves, where are there more? So what I do is I look at my x's and I say, where are there more? Well, there are more at the top. So I put the x at the top. And then I say, how many more? I have 8 at the top compared to 2 at the bottom. That would give me 6 more at the top. And then my y's, where are there more, top or bottom? There are more at the bottom, y to the 7th. And then how many more? 2 compared to 7, there would be 5 more at the bottom. So I put y to the 5th at the bottom. That's going to, again, help me avoid those negative exponents. We'll talk about negative exponents next time. All right, we'll do a few more examples. 6 over 12, we're going to need to reduce that. That doesn't divide out into a whole number either, so we'll reduce it. Each of those can be divided by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. And then I look at my a's. I have a to the 11th at the top, a to the 3rd at the bottom. So there are more a's at the top. How many more? 8. Then I notice I have a b, but there's no other b's. So I'll just leave that b where it is. If it doesn't have an exponent on it, we know it is an invisible 1 right here. So this answer, you probably will see it written like this, without this 1 in front and without the 1 on the B. The next example, this is going to be multiplying, so we're going to multiply the numbers and add the exponents. -8 times 6, -48. Use your calculator if you don't know that one. And then x squared, but I don't see another x in the second part right here, so I just bring down x squared. There's nothing to add it to. And then my y's, I combine them by adding y to the third, add that to the exponent y to the seventh. That gets me y to the 10th. All right, for part F, you're raising this power to a power. So we first got to deal with this 5. This 5 also has to be raised to the third power. So I want you to think about that as 5 to the third. 5 to the third means 5 times 5 times 5, which gets me 125. Now for the A, there's an invisible 1 right here. And so I'll multiply the 1 times that 3 on the outside to get 3. Then I'll multiply the exponent of 2 times that 3 to get b to the 6th power. All right, and for the next 3, this might be a good time to pause the video, write these 3 problems down, and give them a try on your own. We learn math best by trying a problem and then seeing if we got it correct, and then correcting any mistakes that we made. So I invite you to pause the video right now, write these down, try them, and then see how you did. Hopefully you got a chance to try that. We'll start with part G. This is another raising a power to a power, so we're going to do -3 to the 4th power. And I'm going to keep that in a parenthesis. It's really important with a negative there. And then you're going to multiply -3 times -3 times -3 times -3. That gets positive 81. And then you would have multiplied 12 times 4 to get 48. And 8 times 4 to get 32. Those are some pretty big exponents. That's okay. Powers to powers, those numbers get big pretty quick. Part H is actually a multiplication. So even though they have this in parentheses, you're still just multiplying. Remember, parentheses next to each other is multiplication. So we're going to be adding the exponents. There is an invisible 1 right here. So I'm going to add the x exponents to get 5. And I'll add the y exponents to get 20. For our last one, division. I have this number 20 in front, but I don't see any other regular numbers. So I'll just bring that down into my answer. And then I compare my A's. Where are there more A's? At the top. How many more? Just 1. Where are there more B's? At the top. How many more? 9 compared to 4 would be 5 more at the top compared to the bottom. Now, if you notice, I don't have anything at the bottom here. You could put a 1 there if you'd like. What you will most often see is people leaving the 1 completely off, and that's okay as long as it's in the denominator. So you'll probably see an answer written as 20A. They'll leave the invisible 1 off, and then b to the 5th. And dividing by 1 doesn't change anything, so they'll probably leave that 1 in the denominator alone. All right. Really good work today. If you have any questions, please let me know.